A sum of $20,000 is invested at 5% compounded quarterly. A. Find the amount in the account after 15 years. B. Find the number of years until $30,000 is in the account. Part A. We'll start with the compound interest formula. We know that A amount equals principal times 1 plus interest rate R over number of times compounded per 1 year n raised to the nt power. So find the amount A when principal, $20,000, is invested at interest rate of 5%. We'll change that to 0.05. N would be 4 since we're compounding quarterly, raised to the 4t, 4 times 15. N is 4, t is 15 years. And we'll have our calculator crunch the numbers for us, and we will get the amount $42,143.63. B. Find the number of years until $30,000 is in the account. So again, we'll start with the compound interest formula. R over N raised to the nt power, and the amount will be 30,000. So A will be 30,000. Our principal, 20,000. Interest rate stays the same, 5%. Over N is 4. And we're going to be solving this equation for t, trying to figure out the number of years, or how long will it take for this to happen. So N is 4 and t stays t. So we're going to solve this equation for t. So let's start by dividing both sides by 20,000 and also taking the 0.05 and dividing it by 4. 30,000 divided by 20,000 is 1.5. And on the right hand side we're going to have 1 plus 0.05 divided by 4. That's going to give us 1.0125. That raised to the 4t power. So again, what happened there, I divided both sides by 20,000 to get the 1.5 on the left, and then I simplified the expression 1 plus 0.05 divided by 4, giving us 1.0125. Now we're ready to switch this or change this into a logarithm statement. So we're going to take the natural log of both sides of this equation. So we have the natural log of 1.5 equals the natural log of 1.0125 raised to the 4t power. On the left hand side we still have the natural log of 1.5. On the right hand side, the power property for logarithms says that we can bring the exponent down in front of the logarithm. So the natural log of 1.0125 raised to the 4t is the same thing as 4t times the natural log of 1.0125. So it gets the exponent, it gets the variable out of the exponent position. Now solving for t, we'll divide both sides by 4 times the natural log of 1.0125. So we have the natural log of 1.5 divided by 4 times the natural log of 1.0125. And that is equal to t. And when we crunch the numbers on our calculator, we will get approximately 8.2 years is approximately equal to t. So answer to B, 8.2 years.